So we're going to get started here. Welcome everybody to the April Interoperability and Technology ESIP Tech Dive series. I always just start off on this page in case there's some newcomers. I see some familiar names, but I see a few names I don't recognize, so welcome. If you got forwarded this email, you can join up for the list, the email list here with this join button. And if you want to see our previous activities, you can look at this list here. And we've got, I just want to remind everybody that every talk that we do is recorded. This one's being recorded too, so don't say anything super offensive. And and the last presentations we had were really pretty cool. They are on Esri technology of web app builder and story maps, so go check those out if you missed them. And next month we're going to have a talk on Terra.js, which is some open source technology for web portal development, which is pretty cool. But today we have Drew Bollinger from Development Seed talking about processing planetary data, scale data in the cloud. And this is sort of a little bit of a follow-up to, in a way, to our Google Earth engine talk that we had a few months back, and Ted suggested that we get Drew to give a talk. So you can see Drew there. and I am going to flip the presentation over to Drew now. So I'm making you the presenter. And you should have the ball and should be able to share your screen there.
There we go. I'm actually going to disappear from video, but Rich, can you see my slides now?
Yes, they look good.
Oh, sorry, you said yes?
Yes, they do look good.
Okay, excellent. Cool. Well, hey, thanks Ted and Rich for setting this all up. Thanks everybody who was able to join. I'm Drew Bollinger from Development Seed. This talk was born out of originally a tweet that I will show later in this presentation. I was pretty excited about some of the processing speeds we were able to achieve on processing Landsat data on the AWS cloud infrastructure. And that tweet has sort of taken on a life of its own, and Jed Sundwall from the Amazon Web Services team doing their public open data, he has sort of taken that and run with it and used this tweet that I'll show later to talk about the power of doing processing in the cloud and kind of what's new in satellite imagery processing that has made this all possible. So yeah, first slide, that is me. I didn't include any contact information, but I think it's pretty easy to find Development Seed or me, Drew Bollinger, online via the standard mediums or Twitter or just our website or anything like that. If you have any follow-up questions, would love to hear from you. So to get started, I wanted to talk a little bit about, we're not going to cover really any one specific tool, although I did end up doing a little bit more of an infomercial for AWS than I imagined I was when I set out to write these slides. But instead of really focusing on one tool, I want to talk about what's happening right now with the amount of data that's being made available and an approach to making this data available in really good ways that allow this data to talk to other data and be distributed very widely, be machine readable, be able to be published in a lot of places without necessarily suffering from any type of vendor lock-in. So the thesis, if you will, that's maybe a little high-minded for what I'm intending, is over the past few years, and a lot of this was really led by Landsat data finally becoming open, which was a tremendous achievement, we've started to see tons and tons of Earth science data made available, not just to scientists. So we're seeing this made available on a variety of kind of data portals and FTP servers and all over the place. And the point is that it's getting into hands of journalists, it's getting into the hands of developers, and in a broader sense, it's getting into the hands of decision makers. And in response to this, we really need to start, and we have been doing this, the we as kind of the global we, and I'm sure this includes a lot of folks on the phone call, is changing the way that we package and share the data so that it's more easily distributable, so that it works across more platforms and in more tools, and that's how we end up with a better end product while we're sharing this data and sharing these processing algorithms. This is probably the most important slide of the whole presentation. Just one word: apps. I'm not saying that I think this is all this data is ultimately gonna end up in native apps that you download on the App Store on your iPhone, but I think making data available in that form actually makes it possible to make an app, but also we're going to see web apps, we're going to see Siri apps, we're going to see Alexa apps that start allowing you to ask questions, maybe quite literally, of the data that wasn't possible 10 years ago or something like that. So instead of having to always have a GIS analyst in-house, you're going to be in a spot where we're making all this data available and we're making it so interoperable that we can say, Siri, tell me how the urban extent of Hanoi has changed over the past 5 years, and maybe it tells you a percentage, maybe it at some point gets a visual interface and shows that information to you. The point is that we're getting from a place where instead of just downloading a bunch of Landsat scenes and doing the processing yourself and running these things as one-offs, we're actually getting to the place where we're connecting the data to the places where it's needed in a really interesting way. And I think at the same time, there's sort of an acknowledgement here that at least at Development Seed, we are definitely not scientists. We don't have any satellites or anything like that. What we're really interested in doing, and not just us, but in encouraging other folks to do, is find the experts. I think a lot of people on the phone call probably fall into that category. Find the people who are great at orthorectification. Find the people who know how to do the necessary corrections to get accurate surface reflectance values. How do we get the data from those folks, which is amazing and so deep and so kind of true and scientific quality, and then how do we start getting that data into the hands of decision makers? And how do we do that in a way, like I was saying before, that keeps the friction of that whole process down while still retaining the integrity of it? So I'm going to take, that was maybe a little more high-minded than I ever intended, but I want to take a step back and just talk through a little history of how we at Development Seed started working with satellite data, kind of the things we've learned during the process and how that got us to where we are now, and the type of cloud processing and very scalable processing we're doing today. So it started, I'm going to get the dates wrong, but I think summer of 2014, we were actually doing some Landsat imagery processing and some other, I think, digital globe imagery processing of stadiums for the World Cup that year. And at the time, we were following a Mapbox blog post, which is very high in the Google search results if you ever want to put together your own imagery. I think it's like, top 5 of I'm using GDAL and I want to combine some Landsat bands. And at the time, we were using Earth Explorer or something similar to download this tar file. Had all it was just one big, maybe like 1 gigabyte zipped file of all the bands. we would take out the bands we needed, so band 2, 3, and 4 for Landsat imagery. To make this true color image, we would do some manual color correction to make it look pretty, as you see here. And then, we kind of had our image. That was the end. And I think while we were doing that, we recognized, I'm sure, a lot of the pain that you all have felt in installing these tools and compiling these tools and doing some of the manual processes associated with satellite imagery processing. And we thought, this is something that we want more people to be able to do. And so our introduction to the space really began with kind of that question or that intent. And that first Python package we created was called Landsat-util, for Landsat utility. The idea was from the command line, you'd be able to search, download, and then process Landsat images. And you wouldn't even need to go into a web portal. You wouldn't have to log in. You would just have that data immediately available. And that was already really taking a pretty big step towards the goal that I was talking about initially, which is how do you reduce the friction of getting this amazing data that USGS is producing and get it into the hands even faster of, in this case, we saw a lot of nonprofits actually take this up because they didn't have maybe the funds to hire their own GIS analysts, but they maybe had one person who was a little bit interested in it and knew they wanted to start processing some Landsat data and maybe see change in forest cover in the Amazon. And so how can we start building tools that enable those people access to this data and the information that it entails? As part of that build, we also built Landsat API, and this link actually is a little bit of a lie. It links now to what we call SAT API, which has both Landsat and Sentinel-2 data in it. But the idea is USGS for a long time was making this full CSV available of every Landsat scene and all the associated metadata. And that was incredible, right? You could see any Landsat scene, you could have all the metadata available, but it wasn't sitting somewhere kind of easily queryable on the web. And with all respect in the world to our developer here, Ali Reza, who first set this up, it actually is pretty simple in some regards because we did take a CSV and we just, I think, put it in an Elasticsearch. At least that was the first instantiation of it. We put it in an Elasticsearch dump and we said, start querying this, start searching for things on this data. And now if you want to say, look, I want a Landsat image on this date, you have a really simple, transparent API to get that Landsat image. The next step in that was building a web browser for this that sort of took these same ideals into account. And so this was done in conjunction with a satellite startup called Astrodigital. We built a UI that we actually wanted to take a lot more inspiration from sites like Airbnb or Redfin or Pinterest or things like that, and say, it seems a little bit cheesy, but what if you could search for satellite imagery that easily? And you say, I want cloud cover under this percentage, and I want to just click on it and I want to download it. And so that was we went through a handful of iterations, but that was the inspiration behind building Libra. Is how do we get out from behind logins, make this a really one-click, easy process to be downloading, and then start using the satellite imagery. And so that is also an open source project, as are all of these. So these are all links, and hopefully we'll be able to send out the slides for people to check out after the call. So these are all open source GitHub repositories. You can check out all the code. I encourage PRs. We would love some help on some outstanding bugs on some of these. But the idea, and then these sort of coalesced into a larger organization called sat-utils, which has processing scripts and downloading scripts and API like setup scripts for Sentinel, MODIS, and Landsat. But the idea behind all this is let's open this up and keep lowering the barrier to getting to the data that's made available through USGS, through NASA, AROS, through all these groups, through ESA, and just continually lower that barrier to data into decision making. So this is just this is my sort of visual representation of the API. You can see you just go to api.developmentseed.org/satellites, and it will show one record of this. Actually is a Sentinel image at the time, and this is a little bit of just a metadata dump, but it allows you to do things like search for a given date, search for less than a certain cloud cover. Maybe you only want daytime or nighttime scenes. Maybe you only want scenes in a given area. And sort of the power of having all this available on a web API is actually what allowed us to build tools not only like Landsat-util, but then also like Libra, and has empowered a lot of other people. I don't know if anyone here is familiar with like Vincent Sarago's work, Remote Pixel, but he's done some incredible work in pushing the satellite space. And a lot of it started with just making the data more open and available. Yeah, so as I mentioned, check out sat-utils, and then here is Libra. I can say this as sort of the original designer. It probably needs a little bit of design work and reskinning, and happy to have help in that regard, but I think it sticks very well to its core principle of doing that one thing well and letting you just click on images, being able to really easily filter between dates and then get that image. While this was all going on, the folks that I mentioned at the beginning, Jed Sundwall over at AWS, did something pretty incredible, which is the way we were downloading everything before, either through the USGS portals or there was a Google mirror for all the Landsat scenes. So the way we were downloading all this Landsat data before was it was a 1 gigabyte zip file. You would download it, you would extract the bands you need, and then you start doing the processing. AWS said, we're interested in hosting a lot of Landsat data, and we want to make this publicly available. And we're going to host it as just the geotiffs. We're going to have some metadata up there. We're going to have a thumbnail, a little index.html file, and we're going to make this as frictionless and as easy to use as possible. And so sort of Landsat on AWS was born. They publish all the bands separately. They are very small files. They actually publish the overviews as well. So if you want to do things like dynamic tiling, you can do it directly from the hosted Landsat buckets. And this was, I think, I'm sure Jed has all the stats to back this up, but this was a very successful program for them, both in terms of, getting people to use Amazon services, but also in terms of making this data incredibly available and as frictionless and as usable as possible. And so the aforementioned tweet and kind of the picture that born this talk is we had been doing a lot of processing for this company, Astra Digital. I'll talk about that more. But when we have to go back and process Landsat scenes before 2015, which is when AWS starts hosting the archive, it actually takes us a while to do the processing, because even when we're doing this automated processing, and even though we removed a lot of these manual steps, we still have a pretty big download because we're downloading all the bands. And then we have to unzip the file, and then we sort of piece it back together and do the processing, which is pretty quick depending upon the size or the location of the image. What Landsat on AWS allowed you to do is just download the bands you needed. Nothing is zipped. The files are compressed. And in fact, you can actually do windowed reads. So you can read a certain portion of the TIFF directly on AWS without even downloading the entire band. And you can see, I think the y-axis, I had very poor labels on the chart, but the y-axis is total seconds of processing time, and then the x-axis is the date of the imagery, where the earlier dates are only hosted on either the USGS or Google servers, and things to the right, we're actually. You can see that those things are only taking about 20 seconds for processing, and because of all those things that AWS had done to make this data more available. And Jed likes to joke, I forget exactly the calculation he did using this data, but he says that he saved 250 days of my life on image processing by hosting all this imagery in the way that AWS did. So I sort of continually owe Jed at AWS some thanks for doing that for me. The next thing is in doing work with the startup Astrodigital, we started using a lot of MODIS imagery, and we were using it for some NDVI analyses. Again, incredible data. Everyone who works on the MODIS team at NASA and takes any part of that process is doing incredible stuff to create this data in some sense. And we wanted to recognize that by making it more available in a really similar way. So in partnership with Astrodigital, we wrote some ingester scripts, a very small little server which is nightly polling the available MODIS imagery, and also puts that up on AWS, and this is again through the Amazon public data sets, open data team, both Jed and then now Joe Flasher, who's instrumental in making all that happen. And so the idea, and I'm actually going to click a link, and Rich, just holler at me if this somehow messed up the presentation. But actually, I want to look at the link first, which is, the nice thing about this is we have a really predictable URL. So you can see we're looking for this certain MODIS product, MCD43. It's a 16-day composite product, but it actually, the version 6 is pretty scaly. It's a really high-quality product for surface reflectance, and does a lot with taking best pixels and removing clouds. So again, like an incredible product in terms of everything that was done to create this data. And now we have this link. We sort of always know where this image is going to be. We see the, oops, I clicked again. We see the kind of path and row signifiers. We see the date. And then we actually can just go over to this index, and we'll see the thumbnail. And then instead of the original HDF file, we've done the same thing, which is break this all up into band by band geotiffs. And then also we have the quality bands, and we have overview files for doing on-the-fly tiling. And so all this information is easily searchable, is very machine readable. And you can set up your own API to pull from this. You can build your own UI on top of this. This distribution of the data really plugs in nicely to almost anything you would want to come up with. So this is all the other, Mapbox or Carto or Esri libraries. But the other thing is you can just come up with your kind of anything you're looking for that is right for your set of decision makers or your set of developers. It gives you an incredible amount of freedom to be using this very powerful data, and then taking it to the places where you need it. And then you see at the end here, we're also making all the original metadata available as a JSON file. I think we had talked also about maybe retaining the XML link in there as well, but I think somewhere in this giant JSON file it links back to the original metadata as well. Doing that, again, extremely important, having all this metadata available, allowing you to make this thing searchable, and I think for a lot of people on this call, probably very importantly, letting you retain kind of the original provenance of the data, knowing these sources, knowing what kind of corrections and manipulations were done to everything, and having that very transparently presented to the user.
So Drew?
Yeah.
So you guys were involved with taking that MODIS data to Amazon, or how did that work?
Yeah, so we actually just search it on the, I'm going to forget the name, CMR, the metadata repository hosted by NASA. And then the only piece that we're doing is we're taking it from HDF, breaking it all out into those geotiffs, kind of reformatting the metadata into a really readable format, and then pushing that all and uploading it to Amazon. So we're doing that, it's hosted all by Amazon, and we're doing that through Digital, the startup that I mentioned earlier.
Okay, thanks.
So yeah, we really like this approach. We think there are incredible amounts of benefits to publishing data this way, and I just want to talk through what, again, it was an amazing process. It started with Amazon being very transparent with the community. They set up little just phone calls with people who are interested in use cases for this type of data. So they said, hey, let's find some people who are interested in MODIS, are thinking about using MODIS in their product or in their app. Let's get some folks from NASA and NOAA and USGS on the phone and talk about how we can make this data available in a way that really works for everyone. Then the next thing is, I had mentioned this before, but really predictable file naming structures. Being able to go back and access data, sometimes you sort of take this for granted that you can construct a URL with a certain date and a certain path and knowing a certain product. But not all services are like that, and being able to present data in that way allows people to build really reliably on top of your service. Thumbnails, they're fantastic for building imagery browsers. They're also fantastic just to kind of gut check, make sure you're in the right area, make sure there aren't too many clouds, being able to see that. It seems a little bit like a frivolity or something like that, but it's actually really helpful to have thumbnails available and connected to the metadata and the downloads of all these images. Again, I had mentioned sort of accessible metadata, making it machine readable, getting it all in one spot, really searchable. And then, yeah, talking to folks about the file format. I'm a big fan of GeoTIFF. I think there are certain cases where you want to be using HDF, although the tooling for it is a little bit trickier in terms of maybe you have to recompile GDAL. And then I think the same is true sort of the Sentinel data on AWS, which again, fantastic undertaking, but that's published as JPEG 2000, which again, it just takes a little more compiling and installing different drivers to make that available. So I'm sort of pushing GeoTIFF on anyone who listen, but definitely understand that there's needs for other file formats and other use cases as well. Cool. And then again, the idea behind this is making this data really available and really easy to use in all sorts of kind of downstream decision making. So with that company that I mentioned earlier, Digital, they were able to take all this imagery and create change maps of forest cover. They actually are still working on getting their satellites in orbit, but as a satellite company, for them to be able to sort of compete and be able to really easily show this type of data and show this type of product is amazing in some ways, because they're not doing any of this analysis manually. They're just able to kind of ship these things down because of the way the data was published and made available. Another thing is, when this data is all available via Amazon and other services that are trying to make this type of data available in a similar way, it actually enables you to really easily do large-scale computation. Machine learning is one example that we've actually been cranking on for a while, and the reason for that is you don't have to download all the imagery ahead of time, and you don't have to worry about setting up your own tile servers or making all this available in an easily consumable format. When all that data is really easy to search and the metadata is there, you can do things like windowed reads, or you can read from it like via dynamic tiling. It actually enables you to do a lot of more powerful things like these large-scale computations. And this GIF is, in some ways, not very a practical example of this, but because it shows off the speed that you can do this machine learning at. But this is a machine learning algorithm that we actually trained on digital globe imagery, actually. But because it's all made available via tiles, the imagery, we can run the machine learning algorithm tile by tile, and you can actually see it happening in real time. So this is sort of a machine learning tile server, which I don't know that you would really need to set up ever. You'd probably want to do these results in a giant batch and get whatever your given analysis is as the output. But the idea is being able to make this data available in that format is what enables you to do these large-scale analyses.
So was that, just for clarification, was that a real-time demonstration of an algorithm to determine roads or something?
Yeah, that's actually doing some road tracing. It wasn't trained over this area. It was trained in a nearby area, and this is in the Philippines. And as it sees each image of each tile, it is predicting the roads for that tile, and that's the yellow overlay.
Okay, thanks.
Cool. And so all of that infrastructure and setting things up in that way and being able to distribute and publish data like that is what allows us to build really powerful processing pipelines in the cloud. We've done it a few times in slightly different variants, and I won't share a ton of specifics because I think this is kind of really custom depending upon what type of processing you're doing, but we do have a bunch of tools made available, again, in that open source repo, sat-utils. The idea is once you have all that available, once you have your open processing script as a Docker image sitting around somewhere, then it becomes a lot easier to build these large-scale processing pipelines. And you can build them in a really modular way, and it makes them very easy to debug. It makes these things really easy to understand and reconfigure, and it's sort of the de facto standard for modern infrastructure building. Is the reason people like doing things on the cloud is how modular you can make everything, how easy it is to change out one piece if needed. And so that was really the approach we took in building these three products. And I think I have kind of one slide on each, although I won't really go into the details. The idea is once you have, if you see sort of at the bottom of the image here, we just have one thing that says image processing worker. And that's just one Docker image that you tell it, hey, I used something really similar to Landsat API to find an image, and now I want it processed in true color, or now I want it processed with, as an NDVI image or urban false color. And when you have things set up the way we were talking about before, you can just send that information to a Docker image, have that running somewhere on the cloud, and it can process things incredibly quickly and in an incredibly scalable way. And so that last one was just a kind of rough outline for the astrodigital processing pipeline. We're doing something similar for NASA right now as a prototype. And the idea is we're trying to take some legacy code that is written in a bunch of different languages. It could be any point from once the imagery gets downlinked to a ground station, anywhere before it gets to the user. We want to be able to take all sorts of processing code and rewrite those into Docker containers and then be able to run this as a very long, well, not necessarily very long, any length pipeline to handle any number of different combinations of the types of processing that are going on. So you can see, again, this does look a little bit maybe dense, but the idea is so many of these parts are replaceable because they're much smaller modules, and you don't have to build the monolithic system that you would have necessarily had to do in the past. And I actually don't have one for a diagram for MODIS. You can go check out the MODIS ingester repo. It's pretty simple. I think right now we're just running it actually on one EC2 instance, but it's really easy to deploy kind of anywhere or scale up and down if we decide to go back and start covering a lot of the back catalog of MODIS as well. Cool. I just have one last thing, which is kind of our current approach to how we're building all these things. And I definitely want to keep time open for questions. I know I've kind of covered a bunch of things and would love to help anyone kind of understand things better or help clarify. So this last piece is how we're doing things now. We're starting to use a lot of Lambda functions on AWS. The idea that these are the very smallest non-server using pieces of code that we could be running for our processing. One of the problems, however, with doing a lot of imagery processing is GDAL is not the easiest installation process. So I did just a quick search this morning for how many people have errors. Actually, 242,000 might be pretty respectable. That's actually pretty low. But I think being able to have a package for all the GDAL dependencies you need, maybe you install something like Mapbox's Rasterio that's helping you do your imagery analysis, being able to package up a bunch of these dependencies and make it available as a Lambda function base. So you need to kind of package that all up to be able to run, to have that environment ready to be able to run Lambda functions. That is a tricky thing, and it's something we're looking to publish an open source repo on, and we'll make available as an open source kind of Lambda base that we think we're thinking of calling Geolambda. But the idea is, how can we help, again, lower the barrier to other folks setting up these type of processing pipelines, being able to do imagery analysis either on the fly or in these big batch, very quick processes.
Hey, Drew?
Yeah.
Would Conda install help you out there? Is there a reason you can't use that? That's the way we've been installing GDAL, for the last year or so.
Yeah. I guess I'm not sure that Conda is small enough. There are size limitations for installing on Lambda. So I don't know what the we end up putting a couple other things on each instance, and I tend to shy away from Conda just because it ends up with a little bit more things you don't need on the instance if you want to keep your code, your total package size really light.
Okay.
Yeah, and the other thing is being able to install it, across kind of a variety of different platforms. It isn't always an issue when you're doing this. You can know your instance type if you're running it on AWS or DigitalOcean, something like that, but being able to install it kind of across new environments and making it really scalable, it's a lot easier if those things are all packaged up for you as a base for a Lambda function. And then the nice thing about getting away from server-driven architecture, although I will say we aren't totally off servers, anything like that, is Lambda functions or other, similar serverless options, they don't go down. So this is actually a real Slack chat I took from another one of our projects. I cut out the client name because I don't want them to know how many minutes this was down while I was panicking about it. But the idea is you want your processing pipeline to happen very fast and kind of one after the other, and maybe you orthorectify, you do some sort of geo-referencing, maybe your particular process is extract the contours from a Landsat image or something like that. And if it's set up on a bunch of servers, a bunch of instances, that can go down. If you build it in a way where you have a lot of little processes and a little lambdas everywhere, those can fail all you want as long as you know to retry them. You actually don't worry, and you're a lot more resilient to the type of failures that can occur during processing. For instance, I'm sure everyone has had the problem where they tried to process something around the anti-meridian, tried to go over 180 degrees longitude and had some library or another fail at that point. You don't want your whole server going down when those type of things are happening. And there are a couple Amazon products that have attempted to abstract that idea. So we did a little bit experiment with using AWS Data Pipeline. That is more set up for scheduling and orchestrating EC2. Now they do have the step functions, and I'm not quite as familiar with those, but some of the folks on our NASA team are working with those. It's a way to orchestrate lambdas and help connect all these very small processing functions together in a chain of different operations. And the stuff that's happening there is really interesting. Cool. So that is all I had. I think, Rich, you had given me this warning, which is it does a little bit sometimes feel like talking into the void. So I would love to hear folks' questions. How can this be more helpful to you? I think, again, I just want to reiterate, I think a lot of people on this phone call are the ones making this kind of data and helping make this available. How can we help you make this data more available to people? How can we get your awesome data in the hands of more people and make it more usable and get it into kind of real decision-making processes?
Cool. Well, thank you so much, Drew. That was an excellent talk. It was, before, actually, I'm going to unmute everybody so you can ask your questions directly, but I do see that there is a question already in the chat, which is actually a question that I was going to ask. How would you characterize, what you presented compared to, the sort of the Google Earth Engine? I'm sure you know a little bit about that. I mean, I could guess the answer, but I'd like to hear from you.
Yeah. So it's a few things, and for one, they actually did just recently open source a bunch of pieces of the Google Earth Engine kind of ecosystem. We're really looking forward to playing around with that and seeing how it integrates with a bunch of other services. I think the idea is that is kind of one pipeline, and if you do find that is meeting your needs kind of as an end user, I wouldn't say to stop using Google Earth Engine or try something else. But these are more like the tools that you would use to set up a Google Earth Engine clone or your own version of Google Earth Engine, but it only does the one thing you need. So in some sense, it's not exactly comparable because that's kind of a preset architecture. And I think we're a little bit more talking about an approach to publishing data on one end, but then doing processing with kind of a variety of tools. And I think if there were Google Earth Engine alternatives that plugged in and did this processing even faster, then we'd be, you know, like happy to kind of integrate and be interoperable with those things as well.
Right. So I mean, you've got kind of this Google Earth Engine, yeah, as you said, I guess it's sort of like a limited high-end tool set or something, and you have a lot of high-performance tools, but it's the whole spectrum of, I mean, you've got really the low-level power to do anything you want, essentially.
Yeah.
Yeah. Any other?
Yeah, I see there's one thing mentioned about Google Cloud. Yeah, they hosted a lot of imagery. I think they still do. We moved off of it for a lot of our things just because they made it available as, it's a little bit less searchable. A lot of it was made available as big zipped tarball files rather than being able to read directly from the bands, you know, nice compressed, tiled, window readable geotiffs that Amazon was making available, although we do fall back on, I think, Google Cloud for the older services as well.
All right, there's another question here from Ted. Who were you working with at NASA?
Who are you working with at NASA? Well, so I will say I'm not the most knowledgeable person about our work at NASA. We are working directly with some of the LP DACs, and I'm going to mess up the acronym, but I think the D is probably data or distributed, but the folks responsible for making this data available and kind of doing all the processing on data before it gets published on a, you know, either Earth Explorer or through kind of Gibbs imagery services, things like that. Right now, what we're doing is just a prototype, but the idea is to be able to move over from a lot of legacy code into more modern, kind of big, scalable cloud infrastructure from sort of the older processing services. But Ted, if you want to know like the exact person or group, I would say email me at Development Seed and I can connect you with the right folks here.
Cool. So Drew, I had another question about you kind of mentioned how it was important to have that sort of naming convention, and you're sort of advocating GeoTIFF. You know, so it's basically, you know, real. You know, I guess we might have, maybe this community probably would have imagined something like a, you know, RESTful API or something like that that would give you, you know, that would land you at the right URL or something, and maybe you're accessing the data from, you know, from HDF. But I mean, I guess and you mentioned like building HDF as sort of the, you know, as a roadblock, or not a roadblock, but maybe a low hurdle.
Yeah.
You know, are there also performance issues, or is it because you're just reading a bunch of small tiles? I mean, we usually think of HDF as being the most efficient way to read, you know, multidimensional binary data, and
yeah.
You know, and being able to dip in and access just what you need. Can you comment on the sort of?
Well, so do you know if that's true remotely as well as locally in terms of ease of dipping in and reading just the thing you're interested in?
You know, actually, maybe Ted would know, because I know they've been working on that.
Yes. Maybe we could talk about this later, Drew. But we're working with also with NASA and with OpenDAT, and also we have another project at NASA that allows range gets against data objects in HDF.
Awesome.
So
yeah,
it would be.
I think from our side,
we're also working with
the
National Renewable Energy Lab and also Amazon on trying to do similar things. So yeah, we're definitely in that arena.
Yeah, and again, I think on one hand, we really don't have a horse in this race in terms of choosing a data format. I think for us, we want to promote what is easiest for the larger geo community to be working with all the time. And if that's HGF, and if that you know, range get stuff goes through, and it is possible to be doing these really easy remote reads on HGF, I'd love to see that and start experimenting with that, and also kind of encouraging that approach as well.
Cool. Anybody else? All right. So I'm not sure, did you show the GitHub repo at some point? It's not your github.com/Drubo, right?
Well, for depending upon which project I was talking about, everything in here does have links. So all these blue things should be links to either kind of blog posts or GitHub repos. And I can definitely follow up with you, Rich, to get some more data out there, or information out there if people are looking for anything.
Okay, so you're going to share this as a PDF or something, and then I can link it, and it'll have the links in it?
Yeah, I'm not positive it would be right of me to talk about open data and then turn it into a PDF, but I will share it in some very easily machine-readable format.
Oh, okay, so sorry, we can just go to that URL up there.
Yeah.
Okay, now that's good enough. Yeah, you don't have to. You don't have to create a PDF. Okay. Well, Drew, thanks very much. I wanted to mention next month, just be aware we're going to meet 2 hours later, because our speaker will be speaking from Australia, and he didn't want to speak at 5 a.m. So we're going to have him speaking at 7 a.m. But just be on the lookout for that. So it'll be 2 hours later at 5 p.m. Eastern in May. But Drew, thanks again so much for showing us what you were into here. This is super cool stuff, and I bet more than a few of us are going to be jumping on and checking it out.
Awesome. Thanks so much for having me, Rich, and great talking to you all. Hope to hear from you all in the future.
All right.
Thanks, Drew.
See you down the road.
Yep.
Thanks, Rich. Bye, guys.
Bye-bye.
Bye.